Okay, welcome back everyone. In this video we're going to be starting a new chapter in which we're going to be looking at solid figures. Solid figures are things like, well, prisms is what we're going to be looking at in this video, and later we'll look at things like pyramids and cones and spheres and cylinders. Those all fit into the category of solid figures. So let's jump in and take a look at prisms. First, a quick definition and some terms that you're going to need to know. The definition of a prism is a solid figure that consists of two bases as well as a number of lateral faces that are going to join the bases together. Now there's some things you need to know about the bases and the lateral faces of a prism. First of all, you need to know that the bases will always be congruent to one another as well as parallel to one another, or technically they exist in parallel planes, but we just kind of think of them as being parallel to one another. So you can see real quick, let's jump down here. I have 4 examples of prisms, right? They all look slightly different. But one thing you'll notice is they all have 2 of their faces shaded in gray. We're going to consider those gray shaded faces to be the bases of these prisms, right? And one of the things you're going to notice is in each one of these prisms, those bases, they look to be the exact same size and shape. And they will be because they're going to be congruent to each other according to, what we know and how we describe prisms. They will also be parallel to each other, meaning that if you extended these polygons and you made them into planes, meaning they go forever and ever and ever in kind of all the directions, they would never intersect each other. And so we can say that those bases are parallel. And you can see that's going to happen in each example that I've gotten down here for you. Now the lateral faces would be the kind of the white parts of each one of these prisms, right? Those are called the lateral faces. They're basically any part of a prism that's not a base. Those are the lateral faces. And if you look at the shapes of them, you'll notice that like in this prism, as well as these last two, those lateral faces are going to be rectangles. Okay, those are rectangles. Even though it looks like in this one, for instance, it looks like this part of it is a parallelogram, you got to recognize that's only because we're looking at a something that's representing a three-dimensional object. And so to kind of get that perspective and to represent that idea of it being three-dimensional, we end up drawing this like a parallelogram, but we would think of it as if we were holding it in our hands, it would be a rectangle. Now these, because they have this first one as well as these last two, because they have rectangular lateral faces, we call them right prisms. So that one's a right prism, and both of those are considered right prisms, right? So those are called right prisms. Now this one here, the second one, you can see its lateral faces, they're not rectangles, they're actually parallelograms, right? So that's a different kind, parallelogram, sorry. That's a different kind of prism. It's called an oblique prism. So this one here is called an oblique prism. Now from this point forward in this class, we are only going to be considering right prisms. So everything we do from this point forward, we're kind of limiting it to just right prisms. So just keep that in the back of your mind. An altitude of a prism is a segment that would kind of join the two bases and be perpendicular to both of those bases. So if I look at this first prism that I have here, this edge right here, and in fact any of these vertical edges, it's got 4 of them that are kind of vertical in this picture, you can see each of those edges is a segment that's joining the two gray parts, the two bases. And even though I didn't draw it, we can kind of say that it's going to be, since this is a rectangle, we can say that that is going to be perpendicular to both of those bases. So this fits the definition of an altitude. So this thing right here could be considered an altitude. So let me just kind of write that in real quick. In any right prism, those edges that are kind of along the sides of the lateral faces, those are going to be considered altitudes of the right prism. Now in an oblique prism it gets a little hairy. Sometimes we end up seeing altitudes drawn kind of outside the prism like I have right here. But like I said, we're not going to be messing with oblique prisms too much, so we can kind of think of the altitudes of these right prisms as one of these edges along these lateral faces. Now the length of that altitude is what we mean when we talk about the height of the prism. So whatever length this segment would be, that's the height of that prism. Whatever length this segment right here. So from here kind of down to this point right here, that is what we would call the height of the prism, right? One thing you might want to make yourself a note of, the height will not always be vertical. In other words, there might be some pictures where the prism doesn't kind of stand upright like this with the bases on the top and bottom. It might be kind of one of these things, kind of imagine it tipped over on its side, where the bases are maybe like the right side and the left side of the picture. In that case, the height would be sort of horizontal. If I could maybe try and do a quick sketch of maybe a prism like this, where we got, you know, a base right here and a base right here. You can see in this case that those bases are like the right side and left side of that prism, in which case the height would be that distance right there. And I can answer more questions about that in class if you need me to. Prisms are going to be classified and named by the shapes of their bases. So in other words, if I look at these, I'm just going to concentrate on the three right prisms down here. This one, its base is a rectangle, even though it looks like a parallelogram. Of course, that's just because we're drawing this in 2 dimensions. If we were holding in our hands, that gray piece would be like a rectangle. So we call that a rectangular prism. This one's base is pretty clearly a triangle, so we can call that a triangular prism. And that one's base is a pentagon. It's got 5 sides, so we call that a pentagonal prism. So that's some of the terminology for prisms. A couple other things you're going to need to know. The lateral area, when we talk about trying to find the lateral area of a prism, what we're talking about is the sum, or adding up, all of the areas of the lateral faces. The lateral faces areas, I guess I should put on there. Adding up all the areas of those lateral faces. The total area, or sometimes called the surface area of a prism, is the sum of all the faces areas. So let's jump right in. That's really what we're going to be concentrating most of our time on in this section, is calculating lateral area, total area, and then later we're going to look at volume of prisms. So theorem 12-1 is a theorem that tells us how to calculate the lateral area of a right prism. And what we're going to do is we're going to take the perimeter of the base, and we're going to multiply that times the height of the prism. So sometimes you'll see this written as lateral area equals capital P times H, where capital P stands for perimeter of the base, and the H stands for height of the prism. And it's going to get sometimes kind of confusing because we'll have H stands for multiple things. Maybe sometimes even within the same problem, H will stand for multiple things. So that part can be a little bit confusing, but I think you'll work it out pretty soon. Now the total area of a right prism, so we would say TA for total area of a prism is equal to the lateral area plus 2 times the bases, right? Because the total area is the sum of all the faces. The lateral area takes into account all the lateral faces, but we still have to account for the 2 base areas. So maybe jot yourself a note that capital B stands for area of one of the bases. And we can substitute in this idea of capital P times H for the LA. So maybe a better way of writing this formula is to say total area is equal to PH plus 2B. P for perimeter of the base times the height plus 2 times the area of the base. So let's take a look at an example where we're going to use this formula. We have to find both the lateral area and the total area of this right trapezoidal prism. You can see the bases are trapezoids here, so we call it a trapezoidal prism. Let's start by finding the lateral area of this. Now we know we're going to take the perimeter of the base and multiply it times the height of the prism. Well, capital P, how are we going to find the perimeter of the base? We're going to add up all four sides. So we have a side of 5, a side of 8, another side of 5, and a side of 14. That gives us a total of 32 for capital P. What's the height of this prism? Well, it's the distance between the bases is a good way to think of the height. So I have a base on top and a base on the bottom. How far is it from top to bottom? It's 12 units. So my height is 12. So if I'm doing the lateral area, I'll be taking 32 times 12. And 32 times 12 would give us 384. So that's my lateral area. Now if I'm going to do the total area, I need to take that lateral area and add to it 2 times the area of the base. So the lateral area is 384, but what's the area of the base going to be? Well, let's do that real quick. The base is a trapezoid, so I know I'm going to take half of the height times the sum of the two trapezoid bases. The height of the trapezoid, see, this is where it gets confusing because we have an H here that's representing height of the trapezoid. We had an H over here that's representing height of the prism. So just try and stick with me on this. Height of the trapezoid is, of course, 4. So I can look at the picture and I can see that this right here is representing the height of this trapezoid. And the picture tells me that that's 4. Base 1 is 14, base 2 is 8. Half of 4 times 14 plus 8 is half of 4 times 22, which will give me 44. So that's my capital B. So I'm looking at 384 plus 2 times 44. Well, that's 384 plus 88. And 384 plus 88 should be 472. So there's my total area. Here was my lateral area. And it's pretty much as simple as that. Now, solid figures also have volume. And the volume of a solid figure, you can kind of think of it as a measurement of how much stuff can fit inside the solid, right? How much water, how much gas, how much sand, or whatever the material might be, how much of it could fit inside this if you had this solid figure sitting in front of you and you're going to pour stuff into it, right? Now the formula for the volume of a right prism is a lot easier than the total area of a right prism. It just looks like this. Capital V equals capital B times H. Capital B means the same thing as it did above. It's the area of the base. Capital H means the same thing as it did above. It is the height of our prism. So what would be the volume of that prism right above? Well, we know we're going to take capital B times the height. We've already calculated capital B right here, right? The area of the base was 44. So we're looking at taking 44, and we're going to multiply that times the height of the prism, which is the distance between the bases. So we know that that's going to be 12 right there. And 44 times 12, let me do that real quick on my calculator. 44 times 12 gives me 528. So 528 cubic units, right? If you were going to try and label this, it would be cubic units, or units to the third power. That would be the volume of this prism right here. Now lastly, we have a problem that's kind of got 2 steps. We have this triangular prism, because its bases are triangles, and it says the lateral area is 156, and we're supposed to use that information to find the volume of the prism. Now, of course, to find the volume of the prism, we need to take the area of the base times the height. Now, the area of that base, well, that base is a triangle. So I know that to calculate the area of the base, I'm going to take half of 5, because that's the base of that triangle, times 12, because that's the height of that triangle. And half of 5 times 12 is 30. Now I'm going to multiply that times the height, but you can see over here I don't know the height right now. That's where this information is going to come in handy. We're going to take our formula for lateral area, LA equals P times H, and we are going to solve this. We're going to put a 156 for our lateral area. We're going to quickly calculate the perimeter of that base. It's a right triangle. Of course, we're missing this side right here. If this side's 5 and this side's 12, the Pythagorean theorem would tell us that this side right here is going to be 13. You can either maybe remember that 5, 12, 13 is a Pythagorean triple, or you can work out 5 squared plus 12 squared equals that missing side squared. But trust me, it's going to give you 13. So that perimeter would be 12 plus 5 plus 13, which is 30. So 156 is equal to 30h. Now if I divide both these sides by 30, 156 divided by 30, that's going to give me my height. Now that's going to be 5.2. So I know now that 5.2 is my height. So I can take that value, I can put it in right here. 30 times 5.2 is going to give me my volume. Now, this is kind of a quirk of this problem. This doesn't always happen, believe me. I'm not trying to show you some magic shortcut for doing a problem like this. It just so happens to work out here that we should kind of know what 30 times 5.2 is, right? Because 30 times 5.2 right here gave us 156. Well, check it on your calculator if you need to, but trust me, 30 times 5.2 is 156. So 156, if I wanted to put a unit on that, would be cubic units. That's our volume of this prism. That is not always going to happen. It just so happened that the lateral area was 156 and it was the same as the volume. That is not some magic shortcut that you can apply to all problems. It was just a quirk of this one. Okay guys, I think that's enough time for today. I will see you in the next video or see you in class, and good luck.